Question 3 of this exercise is kind of a long question. There are 10 parts in this question. In each part, we are given some parameters of an arithmetic progression and we have to find some other parameters. So let's go one by one and solve each question. So in the first question, in the first part, we are told that the AP has A equal to 5, the first term equal to 5, D, the common difference is 3, and the nth term is 50. And we have to find n, and then we have to find Sn, the sum of these n terms. So let's use the relation Tn, the nth term, or actually in this case we can write An. So An is equal to the first term A plus n minus 1 times D. So let's plug in the values. So An is 50, the nth term is 50, the first term is 5, and then we have n minus 1 into D is 3. D is also given to us. So from here we get 50 minus 5, so that's 45 is equal to 3 times n minus 1, and from here we get n minus 1 is 45 by 3, that's 15, or n is equal to 16. So n is equal to 16, and now we can find Sn, the sum of n terms. So that will be equal to, we'll use the formula n by 2 times 2a plus n minus 1 times d. We could use the other formula also, which is n by 2 times 2a times a plus l, or in this case a plus the last term al or an. But let's use this formula. So we will get 16 by 2 into 2a. So a is 5, so 2a is 10, plus n is 16, so n minus 1 is 15. 15 into d is 3, so that's 15 into 3 is 45. So this is what we get, 16 by 2 into 10 plus 45, or 8 into 55, and 8 into 55 is 440. So the answer to part 1 is that n is equal to 16 and Sn is equal to 440. So that completes part 1. Now let's do part 2. So in part 2, we are given that A is 17, the first term is 17, A 13, the 13th term is 35, and using this we have to find D, the common difference, and S 13, the sum of the first 13 terms. So let's use again the relation An is equal to A plus n minus 1 times D, but in this case D is the unknown. So An is A13, so A13 is 35, A is 7, and n is 13, so n minus 1 is 12, so 12 into D. So this is the equation that we get. So 35 minus 7 is 28, so 28 is 12D, and from here we get the value of D. D is equal to 28 by 12, and if we reduce it to lowest form, we will get 7 by 3. So D is equal to 7 by 3. And now let's find S13, the sum of the 13 terms, the first 13 terms. So S13, let's use the formula n by 2 into a plus l, the last term. So n is 13, so 13 by 2 into a plus l. So a is 7 and the last term is 35. So 13 by 2 into 7 plus 35, or 13 by 2 into 42. So this is equal to 13 into 21, and this is equal to 273. So in the second part, the value of D is 7 by 3, and the value of S13 is equal to 273. So that completes part 2. Now let's go to part 3. In part 3, we are told that A12, the 12th term is 37, D is equal to 3, and we have to find A, the first term, and then we have to find S12, the sum of the first 12 terms. So again we are going to first use the relation An equal to A plus n minus 1 times D, and A is the unknown in this case. So let's plug in the values. So An or A12 is equal to 37. This is equal to A plus n minus 1. So n is 12. So n minus 1 will be 11 into D will be equal to 3. D is given as 3. So we get 37 is equal to A plus 33, and from here we get A is equal to 37 minus 33 or 4. So the first term of the AP is 4. Now we will find S12, the sum of the first 12 terms. So to find this, we will make use of the formula n by 2 into A plus L. So S12 will be equal to 12 by 2 into A, the first term, which is 4, plus L, the last term, or the 12th term in this case, which is 37. So this is what we get. So we get 12 by 2 is 6. So 6 into 4 plus 37 is 41. And this gives us 246. So the answer in part 3 is that A, the first term, is equal to 4, and S12, the sum of the first 12 terms, is equal to 246. So that completes part 3. Now let's do part 4. So in part 4, we are given that A3, the third term, is equal to 15, and the sum of the first 10 terms, S10, is equal to 125, and we have to find D, and we have to find A10, the 10th term. Note that even the first term is not known in this case. We don't know A also for this arithmetic progression. So both A and D are unknown. So let's make two equations in A and D. So A3 can be written as A plus n minus 1 or 3 minus 1 D. So that's 2D. So A3 can be written as, in terms of A and D, as A plus 2D. So if we plug in the value of A3, we get 15 equal to A plus 2D. So this is one equation in A and D. And now let's make use of the fact that S10 is equal to 125. So S10 can, in terms of A and D, can be written as n by 2 or 10 by 2 or 5 into 2A plus n minus 1D. So n is 10, so n minus 1D is 9. So 2A plus 9D. And now if we plug in the value of S10 given to us, which is 125, so 125 is equal to 5 into 2A plus 9D. And if we divide by 5 on both sides, we get 25 is equal to 2A plus 9D. So we have two equations in A and D. We have A plus 2D is equal to 15. We have 2A plus 9D is equal to 25. So let's write them here. So we have the first equation, A plus 2D equal to 15, and we have 2A plus 9D is equal to 25. Now by solving this pair, we can find the values of A and D. So let's call this first equation equation 1 and the second equation equation 2. So what we can do is we can use elimination, and we can eliminate the term A by doing 2 minus twice of equation 1, because that will turn A into 2A. So if I do that, what do I get? So if I multiply the first equation by 2, let me write the coefficients here. So this will become 2A, this will become 4D, and this will become 30. And now if I subtract the two equations, on the left side I will get 9D minus 4D, that's 5D, and on the right side I will get 25 minus 30, that's minus 5. So 5D is equal to minus 5, and this gives D equal to minus 1. So the common difference of the progression is minus 1. Now if I plug this value of D into any of the two equations, so let's plug this into the second equation, I will get 2A plus 9D, that's minus 9, is equal to 25, and from here I get 2A is equal to 25 plus 9 or 34, and this gives A is equal to 17. So the first term is equal to 17, the common difference is equal to minus 1. And now A10 is easy to calculate, so A10 will be equal to A plus 9D, and if I plug in the values now, so A is 17 and D is minus 1, so 9D is minus 9, so 17 minus 9 is 8. So the answer to part 4 is that D, the common difference, is equal to minus 1, and A10, the 10th term, is equal to 8. So that completes part 4. Now let's do part 5. So in part 5, we are given that D is equal to 5 and S9, the sum of the first 9 terms, is equal to 75. And using this we have to find A, the first term, and A9, which is the 9th term. So we are going to make use of the relation Sn is equal to n by 2 times 2a plus n minus 1 times d. Because we're given S9, so we have the sum, we have the number of terms, and we have d as well. We don't have a. So using this relation, we can find the value of a. So let's plug in the values. So S9 is 75. This is equal to n by 2 or 9 by 2 times 2a plus n minus 1. So n is 9, so n minus 1 is 8. 8 into d. So 8 into d is 5. So this is what we get. So now let's cross multiply 2 with 75. So we get 150 and bring this 9 down into the denominator. So 150 by 9 is equal to 2a plus 40. 8 into 5 is 40. And if we cancel out the common factor of 3, we get 50 by 3. So we get 50 by 3 is equal to 2a plus 40. And from here we get 2a is equal to 50 by 3 minus 40. And this is equal to 50 minus 120 by 3. That's minus 70 by 3. So this is what we get as 2a. So from here we get the value of a. A is equal to this minus 70 by 3 divided by 2. So minus 35 by 3. So this is the value of a, the first term. And now using this we can also find the value of a9, the 9th term. So that will be equal to a plus n minus 1d. So minus 35 by 3 plus n minus 1 is 8 into d is 5. So this will be equal to minus 35 by 3 plus 40. And if we take the LCM, we get minus 35 plus 120 by 3. So this will be equal to this will be equal to 85 by 3. So 85 by 3 is the value of a9, the 9th term. So the answer to part 5 is that the first term a is equal to minus 35 by 3 and the 9th term a9 is equal to 85 by 3. So that completes part 5. Now let's do part 6. In part 6 we are given a equal to 2, the first term, d is equal to 8, and we are given Sn is equal to 90. And using this information we have to find n and an. So let's make use of the relation Sn is equal to n by 2 into 2a plus n minus 1 times d. So we have Sn, we have a, we have d. What we don't have is n. So let's plug in the values and form an equation in n. So Sn is 90. So 90 is equal to n by 2 times 2a. So 2a is 4 plus n minus 1 into d. d is 8. So 8 into n minus 1. So this is the equation we get. So if we simplify the right side, we get n by 2 times 4 plus 8n. So 8 into n, let me write it as 8n. And then we get 8 into minus 1 is minus 8. Minus 8 plus 4 is minus 4. So this is what I get on the RHS. And if I divide this bracket by 2, I get n into 4n minus 2. So this is what I get. And now let me multiply the expressions on the right side. So we get 4n square minus 2n. So the equation I get is 4n square minus 2n is equal to 90, and we still have a common factor of 2 on both sides. So let's divide by 2 on both sides. We will get 2n square minus n is equal to 45, or I can write this as minus 45 is equal to 0. So this is a quadratic equation in n, and now we can solve it using the quadratic formula and find the valid values of n. So n is equal to I'm applying the quadratic formula now. So n is equal to minus b. So b is minus 1. So minus b is 1 plus minus root of b square. So that's 1 minus 4ac. Now a is 2 and c is minus 45. So we get 4 into 2, 8 into minus 45. That's minus 360. And we have a minus sign which will make this plus. So 1 plus 360 by 2a. So 2 into 2 is 4. So you can verify. If you want, you can pause the video for a minute and actually verify that this calculation is correct. And from here we get, under the root sign, we get 1 plus 360. That's root of 361. That's 19. So 1 plus minus 19 by 4. Now if you take the plus sign, you get the value 1 plus 19 by 4. So that's 20 by 4, or that is equal to 5. And if you take the minus sign, you get 1 minus 19 by 4. That is a non-integer value, and that does not work for n in this case, because n must be a positive integer. So the valid value of n for this part is n is equal to 5. And now the other thing we had to find was an, or a5 in this case. That will be a plus n minus 1d, or a plus 4d, and a is 2. So 2 plus 4 into d is 8, and this gives us 2 plus 32, or 34. So the answer to part 6 is that n is equal to 5, and a5, an or a5, the fifth term, is equal to 34. And make sure that you've understood this this solution correctly. So by applying this relationship, we got a quadratic equation in n, and when we solved the quadratic equation, we got, as always, we got two roots. We got n equal to 5, and the other root we get is minus 18 by 4, which is a non-integer root, which does not work in this case. So that's why the answer for n is that n is equal to 5. So that completes part 6. Now let's go to part 7. In part 7, we are given a, the first term, is equal to 8. The nth term, an, is equal to 62, and sum of these n terms is equal to 210. And we have to find n, and we have to find d. So the formula I'm going to use in this case is Sn is equal to n by 2 into a plus l, a plus the last term, or which I can write as a plus an. So we are given a, we are given an, and we are given Sn. So this will help us find the value of n. So let's plug in the values and see what we get. So Sn is 210. This is equal to n by 2 into a, which is 8, plus an, which is 62. So this is what we get. So we get 210 is equal to n by 2 into 8 plus 62 is 70. So n by 2 into 70, or 35n. And this means that n is equal to 210 by 35, which is equal to 6. So n is equal to 6. The number of terms is equal to 6. And now we can find d using the relationship an is equal to a plus n minus 1 times d. So if we plug in the values now, we will get, we have an is 62, a is 8, plus n is 6, so n minus 1 is 5, so 5d. And from here we get 62 minus 8 is 54, so 54 is equal to 5d, and hence d is equal to 54 by 5. This is equal to 54 by 5 will be equal to 10.8. So d is equal to 10.8. So the answer to part 7 is that n, the number of terms, is equal to 6, and d, the common difference, is equal to 10.8. So that completes part 7. Now let's do part 8. Okay, in part 8, what are we given? So we're given an is equal to 4, the nth term is 4, d, the common difference is 2, and Sn, the sum of n terms, is equal to minus 14. And using this, we have to find n and a. So we don't have a, we don't have n, but we do have the common difference d, and we do have the nth term, and we do have the sum of terms up to the nth term. Okay, so let's first make use of the relation an in terms of a and d. So an is a plus n minus 1 times d. So this means that 4 is equal to a plus d is 2, so a plus 2 times n minus 1, or a plus 2n minus 2. So from here we can write a in terms of n, so a will be equal to 6 minus 2n. Okay, now let's make use of the fact that Sn is equal to minus 14. So Sn, the relation for Sn is n by 2 times a plus the last term or the nth term, so a plus an, and let's plug in the values. So minus 14 is equal to n by 2 times a plus an. Now an's value is known, an is equal to 4, but instead of a, what we can do is we can substitute this value of a that we've calculated in terms of n. So instead of a, let's write 6 minus 2n, and what this will do is this will give us an equation in n alone. So what will we get? So we will get minus 14 is equal to n by 2 times 6 plus 4 is 10, so 10 minus 2n, and if we divide by 2 we get n times 5 minus n, and if we now simplify it, we can rewrite this as a quadratic equation in n square minus 5n minus 14 equal to 0. And if you observe this quadratic expression on the LHS, it's quite easy to factorize. It can be factorized as n minus 7 times n plus 2. So the quadratic equation is n minus 7 times n plus 2 is equal to 0, and the only valid root is n equal to 7. So there are 7 terms in the AP in the progression, and now we can find the value of a. A is equal to 6 minus 2n, or 6 minus 14, or minus 8. So the answer to part 8 is that n, the number of terms, is equal to 7, and a, the first term, is equal to minus 8. So that completes part 8. Now let's go to part 9. In part 9, we are given that a is equal to 3, the first term is 3, n, the number of terms, is 8, and s, which must be the sum of these 8 terms, is equal to 192, and using this information we have to find d, the common difference. So let's use the formula s is equal to n by 2 times 2a plus n minus 1 into d, because we have all the parameters. We have n, we have s, we have n, and we have a, and all we need to do is find d. So let's plug in the values. So what do we get? So we get 192 is equal to n by 2, 8 by 2, that's 4, into 2a, so a is 3, so 2a is 6, plus n minus 1d, so n is 8, so n minus 1 is 7, so 7d. So now we get 192 is equal to 4 into 6 plus 7d, divide by 4 on both sides, so we get 6 plus 7d is 192 by 4, that's equal to 48, and from here we get 7d is equal to 48 minus 6, or 42, and this means that d is equal to 42 by 7, or 6. So the common difference in part 9 is 6. So the answer in part 9 is that d is equal to 6. So that completes part 9. Now finally let's do part 10. So in part 10 we are given that L, which must be the last term of the progression, that's 28, S, the sum of terms, is 144, and we are told that there are a total of 9 terms, so n is equal to 9, and using this information we have to find a, the first term. So we are going to make use of the relation s is equal to n by 2 times a plus L, we have S, we have N, and we have L. So it should be easy to find A using this relation. So let's do that. 144, which is S, is equal to N by 2 or 9 by 2 times A plus L. L is equal to 28. So let's cross multiply 2 with 144 and divide 9. So we will get 144 by 9, that's 16. 16 into 2 is 32. So 32 is equal to A plus 28. And this means that A is equal to 32 minus 28 or 4. So the answer to part 10 is that A, the first term, is equal to 4. And that completes part 10. And with that, all 10 parts of question 3 are done. To learn more about how QMath can help you crack school and board exams, explore QMath Leap, a live online classroom program run by highly experienced and committed teachers.